This is TRS, and my name's Todd. I got some exciting news I want to share with everybody this week. We have officially sold our first engine, which we're very happy about, very excited about. We've been working hard towards that, and all our hard work has finally paid off. So this gentleman and his family come to the shop to take a tour. They're in the shop, walking around. I'm showing them stuff, and then I start talking about the engines, and I tell them the process of how we do it, and my thoughts on machining and my theories on all this stuff. And he stands back after I get done, and he's like, "Why don't you tell everybody this? You've never explained it to me like this, and I feel I understand so much better what you're talking about." And he just wanted to know why I don't share it with everybody. He even suggested I make a video like I am right now of explaining it more in depth of how we do it the way we do it and why we do it the way we do it. Later that night I got to thinking, and I'm like, yep, I need to do that. I just realized I'm not a salesman. I'm not someone that's going to come up to you and sell stuff, and I need to work on that. I really do, because I'd hate you to miss out on a great product here. All right. So this is what we start with when we start building these engines. Is one solid chunk of aluminum, 6061 aluminum. It's cut out of plate to our specific dimensions. We get it in house, and the first thing we do with it is face off this side and drill 4 holes in it. Them 4 holes right there get mounted into our 5-axis fixture, and then we put one more additional hole in the bottom of the block, and that is to dowel it. That we dowel pin the block to the fixture. And what that does, if you ever have any problems down the road, you window one, you beat one with a hammer, cut it in two, I don't know, run it over with your motorhome, I don't know. Whatever you do to it, I'm pretty sure we could fix it. We'll weld it back together, we put it right back in the fixture, it gets located off the dowel pin that's in the bottom of the block here, and we can pick back up. We can, if we come out with new improved port designs, we can put those in it. If, you break it, window it, break a cam, break lifter guides, valve guides, whatever, we can put it right back in and machine it to its original spec. So it's not guessing, it's not, trying to use a hand drill or chuck it up in a Bridgeport and try to fix it. It goes right back into the machine. And while it's in the machine, in the 5-axis fixture, it never comes back out until the block is done, until the block is completely done. It is all done in one fixture. So we bore it in that fixture, we put the sleeve in that fixture, we hone it in that fixture, the valve guides are put in that fixture, they're reamed to size in that fixture, the valve seats are put in, the valve job is put in. I mean, everything is done in that fixture. And another thing that we do is, when let me grab this. Here's a block. This one's not all the way done. But when we machine the block, we machine the side cover right on the block in the fixture. So we take, let me take this apart. So you can't really take this piece, machine it in one operation, take the block in another operation and machine it, put the two pieces together. When you put these two pieces together and they're done in two separate operations, you just take all them tolerances, all the misfits, all that, and you compound them together, and you're way out. So what we do, we bolt the side cover on when it's in the fixture, in the machine, and there we proceed to put both the cam bearing pockets in and the crank bearing pockets in. And what that does is make sure you have perfect alignment between both those. I mean, you get this together, you put that crank in there, I mean, that thing will spin forever. It's perfectly aligned. One other added feature that we do here also, this might be tough to see. Let me see if I can get it. I don't know if it's focusing in or not. But that lip right there, that ledge right there, that ledge fits perfectly down inside here. So you have that ledge helping hold location so you're not just relying on the typical 2 1/4-inch dowel pins to locate your side cover, and that also helps with the rigidity of the block. So there's some of the features that we add into the process of machining the block. You know, when we're out there racing, we're all chasing for that perfect package. You know, we want to see triple zeros across the board. Well, it ain't no different when I'm machining. I want to see triple, quadruple zeros across the board in my tolerances. You know, you machine something that's 5 thousandths out, just picture that being a 5 thousandths off your dial or something. So those are just some of the features that we machine directly into the block when we're manufacturing it. So the next step we're going to go to, we already have engines out there that are proven, they hold together, they work good, but we want to work on power now. We got the mechanic side of it down, so what we're going to work on next is power. This right here is what we're going to start with. This right here, as you can see, is just the top half of the block. I mean, it's just half of it. It's a little bit cheaper and easier to work with than trying to machine up a whole block to flow test it. You know, I'd hate to throw out a whole block just because I, you know, had a crazy idea on the ports and it didn't work out. So we're going to use this. This will mount directly on the flow bench. The air will get pulled directly through the bore. You know, you're not going through the side cover and bending, which will give you false readings. So that's how we're going to do that. We'll make up multiple ones of these, multiple heads, and we'll take it over there. We got quite a few people that are offering up their flow benches because they're excited about our project and really want to help us out. And I appreciate that out there in the community. It really helps get something like this done. Oh yeah, one other thing is, I know some of you guys have already seen this. This is the Outlaw engine that I machined up, and we raced once, and it pretty much failed miserably. It was very weak, very slow. I did a video last week saying how I was going to fix it and everything else. I'm still going to fix it, just haven't done it yet, because honestly, I see the errors in my way in the design of this, and I already have a new design designed up. I got a couple hundred parts over here I got to run. And then as soon as that's done, I'm gonna start making another one of these, because I can't go out like that. I know I can get it done, but this isn't a waste. I got something exciting planned for this. This is gonna be fun. We're gonna do like let's just call it an endurance test. So that'll be something fun to watch. We'll see what it takes to grenade it. So I hope you enjoyed our video here. We're really excited to get going. You know, we got that first sale down. I mean, that feels like a victory in its own. We're gonna, you know, take some of the money from that. We're gonna invest a little bit in shop lights because it's getting kind of dark around here. You know, I swear, about 8 months ago, I came in, flipped the switch, and boom, 40 bulbs went out all at once. But, you know, we've been so busy getting this project done. You know, between the 3 different engines that we developed, machined, manufactured, assembled, and tested this summer, I haven't had enough time to even look up at the lights. But, you know, this winter it's going to get pretty dark out here. We don't want that, so we're going to definitely take some money and invest in some new lighting. We're also going to take some of that money and reinvest it right back into the junior world. We're going to call up some vendors, get some parts on hand, get them in-house. So when you realize you need one of these engines, we can get it to you right away. So I hope you enjoyed this video. Please like, subscribe, comment, share. Let's get the conversation going. Thanks for watching.